Hello, good morning students, and welcome back to the video for the electricity chapter. The topics that were taught in the live classes are being repeated once again over here. So pay attention. If you missed anything, it will be conducted in this one. Okay. So in the previous videos that we talked about the electricity, the links that are shared in the description, those were the videos. But once again, here are the videos for the live classes that are being taught in the school. Okay. So we'll start with the Ohm's law because the electrical energy and the potential difference and everything has been already been taught many times. So we'll start with the important topic, that is the Ohm's law. The Ohm's law states that the potential difference across the two ends of the conductor changes according to the current, or the current changes according to the potential difference across the two ends of the conductor. So for this, a simple activity, let's say that we have connected a conductor in a circuit, okay, and we have provided a potential difference. We connect an ammeter and a voltmeter across the resistance. Okay, now as we increase the potential over here, when we increase the batteries, and therefore we note the potential difference across the conductor as well as the current, we will observe that the potential difference increases, okay, in the conductor increases. And then when we observe the ammeter, we also observe that the value of current also increases. Okay, so the potential difference also increases and the current also increases. So George Simon Ohm suggested that the potential difference across the two ends of the conductor is directly proportional to the current flowing through it. Potential difference across the two ends of the conductor is directly proportional to the current flowing through it. Okay, so this was the relation between potential difference and current flowing in the conductor. Okay, when we remove this proportionality sign, we always have a constant balancing the equation, and in this case that constant is resistance R. R is called resistance of the conductor. R is called resistance of conductor. Now what does resistance mean? Resistance means that every conductor has a ability to oppose the flow of charges. Every conductor has an ability to oppose the flow of charges, and this ability is known as resistance. Okay, so this can also be written as I is equal to V by R, because when you cross multiply resistance, then it will be V by R is equal to I. So you can also find the value of current if you have the value of potential difference as well as the current flowing in the conductor. Okay, this can also be written as this one. I hope the Ohm's law is clear to you. It can simply be defined as potential difference is directly proportional. Potential difference is directly proportional to current flowing in the conductor. Don't forget that. And the graph of potential difference versus current is always going to be a straight line, and you can find the resistance if you take V by I ratio. You can also find resistance by V by I ratio, because V is to I graph is always going to remain a straight line. So whenever you find the V by I ratio, you will always get the resistance as same. You can either take this value V by I or this value. Whichever value you take, you will always get resistance as the same. I hope it is clear to you, students. Quite easy topic which have been taught many times. And now we talk about resistance. Resistance is the ability of the conductor, like I said, and it can also be measured, and the unit of resistance is ohms. Okay, on the honor of our scientist George Simon Ohm, the unit of resistance is given as ohms. Okay, so remember that. And the symbol for ohms is omega, which is a Greek alphabet. So if you find the resistance of a conductor, whether it is 2 ohms or 3 ohms, you write this unit on the back of it. Okay, I hope this topic is clear to you, students. Quite easy. Ohm's law. We'll talk more about this in the next one using the series and parallel connection resistance. Till then, have a nice day.